It's great to be here with you today. Unfortunately, I'm sitting here looking at the Nashville, Tennessee state capitol instead of being there in DC with you guys, which I had hoped to be. But we have an exciting session today, and I want to start off with a few remarks. So I'm gonna put up my slides, and we'll get running on this interesting session. Hopefully, they are popping up as we speak. And in presentation mode. Yes, I think that I see it. Fantastic. Well, thanks again, everybody, for being here. Thanks for the invitation, and thank you, Omari, for all the support in getting this program together. As Omari said, it's new approach to methodologies, NAMs, as we like to call it in the toxicology world. What is being left out? Disclaimer, I'm an employee of an Exponent consulting company. I got clients all over the world, all over the sectors. What I'm talking about today is just my views and nothing associated with any clients or Exponent in general. It's interesting we have to do that these days. But three things I have here to kick us off, and I'm not going to take a whole lot of time because I want to give the speakers as much time as possible. So when we talk about the safety of foods and the components in foods, it's been well associated with understanding that it's driven by hazard and exposure. So hazard is what a chemical is capable or an article or substance is capable of doing. And obviously, if that compound is squirreled away in a bottle somewhere and never exposed to a person, then the safety is assured. If there is exposure, then it's understanding that aspect of exposure and safety. And here I've just thrown up the Red Book figures here that just to demonstrate that in terms of low, intermediate, high toxicological concern from a structure and from an exposure perspective. And then typically in classic toxicology, and it's hard to say classic toxicology, but it's essentially what it is. We've been focusing on in vivo assays in life, limited in vitro and ex vivo opportunities, mainly because a lot of the aspects of regulatory requirements, as you can see in the panel here on to the bottom right of the screen, is where we're dictated in terms of evidence that we need to present to demonstrate safety of foods, whether they're intended or unintended. So toxicology has a goal of helping to prevent or reduce likelihood of diseases or other adverse outcomes on humans and in the environment as well. And our tools are really limited in most cases to, I should put a computer here too, but to laboratory animals and cells that are derived from them. But who we're really focusing on are humans. We've got different ages of humans and different aspects of their life stages. And it's a difficult task to model what could happen in a human at various life stages, at various aspects of their situations from the tools that we have. We've done a great job. We understand a lot. We understand the limitations of our tools, and we understand their benefits. So from that perspective, we're always looking for new tools and new ways to get at protecting the people that are consuming or being exposed to products, especially food. So I've introduced a few things here, and you're going to hear more about this in the future from our speakers. The 3Rs principle: refine, reduce, replace. This is a mantra within toxicology around working towards a new, a better state of understanding and ensuring that we're being responsible stewards of our resources. So we're going to hear more about that in the future, but really I just wanted people to think about that and the fact that while we may have been talking about it for the last 20 years, it was introduced in 1959. So it's not a new premise, and there's a lot of understanding behind it. Where we've gotten to today really started in 2007 with the National Academy's report, Toxicology Testing in the 21st Century, a vision and strategy. This really kicked the wheels off in terms of, okay, we have some opportunities to use the technologies and the new things that we understand and really focus in on what we can do to enhance our abilities. A lot of the focus was working on looking at molecular biology, excuse me, but also the focus on what we used to call big data, and now it's AI in terms of those resources. There's a lot of activity going on. The Toxicology in 21st Century, Tox 21 consortium in the US government that all the major players are involved in. EPA has a nice tool, ToxCast, where it's a place to bring all the data together for people to look at as they're generated. And then you're going to hear more about some of the new technologies that are in the work. So in silico toxicology models, I talked about that. That's computer models using what we know and using the aspect of data manipulation and crunching to get answers that at a much quicker pace and sometimes at a higher level of confidence. And we'll hear about other aspects that are going on. So what gets us to NAMs? So there are a number of issues that we have with NAMs. As you'll see in a moment, there is no one single definition. So it really depends on who you're talking to as to what constitutes a NAM. There are various definitions of various organizations. They generally all circle around the 3 R's principle. And so you could see that in all of those definitions. And they're really associated with new predictive tools and assay types. So uh, whether the definitions all match exactly is sort of irrelevant from that perspective, but it's ensuring that we know what we're talking about. And we're all heading the same direction. It would be nice if we did have a universally recognized definition so that in one geography or in one setting, we are all understanding what that is. So I'm just going to throw some things up on the screen here. EPA has their definition. FDA doesn't necessarily have a definition. But again, focusing on the 3 R's aspects, European Food Safety Authority does have a definition, very concise. European Chemicals Agency, again, really matches what EFSA and what EPA as Health Canada has the same type of thing. The Australian government, in an odd place, albeit, does have those references. And then we have actual committees focused on this here in the U.S. The NIH, NTP, ICVAM, and NICEDM committees are really focused on what can we do to enhance our abilities to streamline the process and to come to better assays, but also making sure that they're fit for purpose and we're not going to be doing something that's detrimental to people in the long term. And OECD obviously has sort of a definition. They've taken a different spin. They've gone down more of the assessment of IOTA's integrated approaches to testing assessment. So really, it's a fit for purpose approach. So in many ways, that works well in terms of you do what you can with the tools that you have at the time to address the question as you know it. So I said, there's many challenges. We got multiple definitions that can lead to confusion. We all understand that biological and physical processes are intertwined and interdependent. And anytime you separate those, we have the possibility of false positives, false negatives, or the aspect that we're just not seeing the whole story. So that rolls into the challenges associated with the biological significance of observed effects and responses following xenobiotic exposures, what we're really trying to as toxicologists, focus on. And then I threw in here something that we struggle with as toxicologists right now, and hopefully maybe we'll have some discussion about that, is we can see effects. Many times the adversity of effect or the adaptive aspect of effect based on the physiology and the biology is a debatable area. Whether that effect is adverse or non-averse is really important into risk assessment. So there is opportunities for us to enhance this in the future. And will NAMS provide us more direction on our challenges? We sure hope so. And with you today, we have an excellent panel of speakers. You've heard from Amari Bandelay from FDA, Suzanne Fitzpatrick. Suzanne, I stole your photo off of LinkedIn. Sorry about that. From FDA, Wally Hayes from the University of Florida, Michigan State, and part of FDA, and then Sharon Donovan from the University of University of Illinois, Urbana-Champaign. So sorry about that slip of the tongue. Being in Georgia, it's a little bit closer to Alabama, but anyway. So we have a great session here today, and I'm going to turn it over to Amari to take it off moving forward. So we'll welcome Dr. Bandelay to the stage. He's a senior advisor for toxicology in FDA's Human Foods Program. Provides leadership on scientific niches and related development of toxicology, and provides advice on NAMs and the support of regulatory assessments in foods. So, Amari, please.